Let's take a look at another example where we're given a quadratic and we want to be able to express the quadratic in standard form for graphing. So for example number 4, if g of x is equal to negative 4x squared plus 8x minus 5, I want us to express g of x in standard form for graphing. And the way that we're going to do this is we're going to use those 7 steps that we talked about in your notes that I gave you. So let's take a look at the 7 steps. And step 1 says to group together our x squared and our x terms. So we're going to rewrite g of x, just kind of grouping together a negative 4x squared plus 8x, and then putting that minus 5 on the outside side of the parentheses there. Now step 2 says to factor out the coefficient of x squared if necessary. And in this case, we do have a coefficient in front of our x squared, and it's negative 4. So I'm going to factor that negative 4 out. And remember, when I factor it out, I have to factor it out of x squared and x. And so when we factor a negative 4 out of 8, remember factoring out is the same thing as dividing by. We're going to be left with negative 2x minus 5. Okay, and again, all we're doing is we're rewriting this in a new form, but algebraically it's equivalent to that same form that we started with. Now the second step says divide the new coefficient of x by 2. So our coefficient of x right now, this guy, negative 2, when we take negative 2 and when we divide that by 2, negative 2 divided by 2, we get negative 1. And then step 4 says to square that number from step 3. So when we square negative 1 squared is the same thing as saying 1. Okay, step 5, add the result of step 4 inside the parentheses. So this 1 that we just found over here, this guy, we're going to add that inside the set of parentheses. Sorry about that. So we have this. We have g of x is equal to negative 4 times x squared minus 2x plus 1. Minus 5. Okay. Step 6 says take the number from step 4 times the coefficient in front of the parentheses and subtract it from outside of the parentheses. So here's what we mean by that step. We're going to rewrite it. Okay, so we're going to subtract from that negative 5 that number that we just put on the inside of the parentheses, that plus 1, times the coefficient in front, which is that minus 4. Okay, so this is the same thing as saying g of x is equal to negative 4 times x squared minus 2x plus 1 minus 5. Now take a look at this next step over here. We have minus 1 times negative 4, which is negative 4. And remember, anytime we have that minus negative, that's the same thing as saying plus. So this becomes g of x minus 4 times x squared minus 2x plus 1 minus 5 plus 4. We can rewrite that as g of x is equal to negative 4 times x squared minus 2x plus 1. Negative 5 plus 4 is minus 1. Okay, and step 7, here's where we kind of tie all the loose ends together. We get g of x is equal to negative 4. And we have to figure out how to factor. Step 7 says to factor the expression in the parentheses as a perfect square. And it will always be a perfect square because this process is called completing the square. So think of two numbers when we multiply them together that give us 1. And when we add them together, give us negative 2. And those two numbers are negative 1 and negative 1. So I can rewrite that as x minus 1 times x minus 1. Just bringing down that minus 1 from over there. And that's equivalent to saying g of x is equal to negative 4 times x minus 1 squared minus 1. So again, this form that we started with, this g of x is equal to negative 4x squared plus 8x minus 5, is exactly the same thing as this g of x. One is written in one form and one is written in another form. But if we were to multiply this out, we'd get back that first form that we started with. But this is the answer. This is what it looks like in standard form for graphing.